More people watched our review and got ready for the test, so great job if you are. We spend a lot of time because we want you to do well, and we know practicing, thinking, and doing a lot more and more things, preparing you to do a lot of things in your life. We're going to be reviewing similarity, and similarity, we learned there's ways to test for similarity, and then there's ways to find missing sides. The basic idea of something similar is if you take this triangle and you make another version of it and you just enlarge it, like when you zoom in on your phone screen, things are going to grow together. So let's say these sides are 1, 2, and 2. And I zoomed in 10 times, right? It would be 10 times 2, 20, 20, and then 10 times 1, 10. So knowing that a dilation makes similar shapes helps us to understand that when things grow, they grow with a scale factor. That's the amount, but each of them will grow the same amount of scale factor. Otherwise, it's not similar. It's not a correct dilation. It's not zooming in or zooming out to the same exact shape. So if I take this as my new shape and my original, we typically take our new divided by our original to see the scale factor. So take a side that matches or corresponds. This side corresponds with this side. And the new one is 20, the original is 2. When we divide that, we get 10, which is what we understood we were doing. We made each side 10 times bigger. So when something grows by a scale factor of 10, all 3 sides must grow. However, there's, in testing for similarity, some shortcuts. So let's talk about first testing for similarity. Then we could talk about solving and the shortcuts. When we're testing for similarity, there are 3 ways. I encourage you to pause the video as we go and see if you can actually do it. Most people think in their head, oh no, I know that. And it's like someone sitting on the couch saying, oh, I could shoot that basket or run a marathon, and they're just in their head imagining it, and it's a total lie. You have to actually write things down and do a practice problem to see if you really get it. So do you know the 3 methods we test for? The 3 methods are side, 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 where we measure the 3 sides to see if they have the same scale factor. Side, angle, side, where we test 2 sides. And then angle, angle, where we just need evidence that at least 2 angles are the same. What we didn't mention a minute ago was that similar triangles also have the same angles. So for example, if I have 60 here and 60 here, 30 here and 30 here, and this is not to scale, right? We would know that at least 2 of the angles are the same, congruent. We can find the third. It's always good to find the third, especially when you don't know if they're similar for sure. So 60 and 30 would mean this is 90. It doesn't look 90. But you see, all 3 are the same and congruent. You can have all 3, but a minimum of 2. So these would be angle, angle, because at least 2 of the angles are congruent and matching. Because when you grow or shrink a shape, the curves and angles stay the same. The angles stay congruent. Okay, but the sides are not congruent, not the same, but have the same scale factor. They're going to grow or shrink by the same ratio. So let's try another angle, angle example. So we might have markings to go with our triangles instead of numbers. And this is a common example where on first glance you might think angle, angle, because there's 2 marked. But let's match them. This one matches with this one. 1 marking, 1 marking. This one has 2 markings, and it's not going to match with this one with 3 markings. So in fact, only 1 pair matches. We would say this is not similar. The squiggly line here is the symbol for similar. And we'll try one more. So here's the way we'll be tricked sometimes. Maybe you have 70, 60, and 70, 50. And on first glance, we'll think, oh, these are not similar. We better say not similar because only one matches, 70 and 70. When when you're given an angle that doesn't match, it's always important to check the third angle because they will try to trick you. We learned that a triangle's sum of the angles will always add up to 180. So if I take 180, take away 70, and take away 60, I'm going to get 50. So in fact, when I find the missing angle, I find that they are similar. So if we ever find an angle and it doesn't look like they're similar, if you can find the angle, find the missing angle. Because in finding it, you might find it turns out that two of them do match. Now we have 70, 70, 50, 50. If we wanted to, we could find this one. Subtract from 180, we get 60. So in fact, they are similar because they have all three angles matching. So one hint is to find the missing angle when we're not given all three, if it's possible. So if they don't give you if they give you markings instead of numbers, it's not possible to find the missing one. So let's see what the other two tests look like. If you're given two triangles, call this one ABC, this one is XYZ. You're going to be given some sides, maybe 12, 3, 9, and 2. What we need to do is match the sides that correspond, or the ones that are in the same position. So to the left of the angle is 12. To the left of the angle marked is 3. Those would go together. Another way to be certain you're matching the correct sides is think of the biggest. This of the two sides, the biggest is 12. And on the other triangle, XYZ, the biggest of the two numbers is 3. So the big will match with the big, the small one will match with the small one. So I'm going to match proportion to see, do the proportions of these two work out to be the same number? 12 goes with 3, and the number 9 matches with the side of 2. There are two ways to test for this. We can cross multiply and see if they're both the same. Or we could just divide this number in a calculator and see if they're both the same. Things that are similar grow and shrink by the same amount, so they have to be the same if they are similar. Let's see. So if I take 12 divided by 3, I get 4. I could have done that in my head. And when I take the second number, it's 4.5. I'll just show you 9 divided by 2 is 4.5. When I test it out, I see that both sides are different. They are not equal. And you might even in math put a not equal sign. So they are not similar. Similar things grow and shrink by the same amount. If I cross multiply it, I get 24 equals 27. And it's also the same test, same idea. They're not the same. They're not equal. So they are not similar. If they were, we would say they are similar by side angle side. But they're not. So our answer is not similar. The third type of problem would be side, side, sides, where all three sides are given for you to match. Maybe 35, 28, 21. And so again, if they're rotated, let's rotate this triangle or reflect it so that 4 is on this side and 3 is, or 5 is on this side. So we don't want to always judge the appearance of the triangle if we can help it. It's always helpful to do what we did a moment ago. Match the big with the big. Match the smallest with the smallest. And then the middle one will be the one that's not marked, middle with middle. That ensures and guarantees we don't make a mistake matching the sides. So 35 is the biggest, we'll go with 5. 21 is the smallest, we'll go with 3. and 28 is the medium. We'll go with the other medium, 4. Let me label these triangles so I can talk about them. Because at the end, we sometimes will write a similarity statement. If things are similar, we will write a little statement. So let's get back to finishing this. And again, don't forget to pause the problem and see if you were able to do it without me explaining it. Then you could fast forward to the answer. 35 divided by 5 is 7. 21 divided by 3 is 7. And 28 divided by 4 is 7. Each side grew by the same amount or shrunk by the same amount. I could match them the other way. Small is 3, it goes with 21. 4 is the medium, goes with 28. And then 5 goes with 35. It'll have 1/7, 1/7, 1/7. It'll still show whether they match or not. So it doesn't matter which triangle we start with. Here on top we did big little, big triangle, little triangle, big triangle, little triangle, big triangle, little triangle. On the second example we did little triangle, big, little big, little big, as long as we're consistent and we match. So these are similar by side, side, side. We have our evidence, which is what we need here. So they often will ask us to write a similarity statement, which is just saying this triangle is similar to that triangle using symbols. So I would say triangle ABC is similar. Now we have to be careful to match the angles that go together. So let's think of it and use our big and small pieces to help us. 35 is in between the big and, 35 and 21 are the big and small. They make up angle C. Angle C is in between the big and the small side. So over here, angle Z matches is in between the big and the small side. So in fact, let me line them up. Angle C goes with angle Z. I then can see that angle A is in between the big and the medium. So I could look around here, which one's in between the big and medium sides? And that would be X. So B goes with X. And then the third one, angle B, is in between the small and medium. Angle Y is in between the small and medium. So angle Y will be the one that matches. I like to line them up above each other. But then we will finish our statement. Triangle ABC is similar to triangle YXZ. This is the way we test for similarity. So we use the 3 patterns, and when there are sides, we test the sides to see if they grew or shrunk by the same ratio. That is what we do here when we are testing. So now that we've talked about how to test for similarity, let's talk a little bit about how to solve similar triangles. So there is a basic idea of solving where we match sides. And then there are some shortcuts. Now we have to remember that the shortcuts, they deal with the sides only, not the bottoms of the triangle. And I'll remind you in a moment what I mean. So the most basic idea of solving similar triangles is that when triangles are similar, and you're told ahead of time, so I'm telling you these are similar, we know that we can match sides that go together. So again, our positioning matters. 10 is to the left of this angle, and it's going to match with 8 because it's to the left of that angle. We can't match big with little necessarily. We can measure the sides. This 10 is the longer side, 8 is the longer side. But sometimes we can't tell for sure. We can use the angles positioning to help us. Or we can use a similarity statement to match the pieces. So in this case, they're lined up the same way. 10 is going to go with 8, and 4 goes with x. We know this because, again, the sides must grow and shrink by the same amount. So the amount this one grew, this one has to grow by the same amount. After we set it up, we cross multiply. 10 times x and 4 times 8. And we finish our algebra solving. So x is going to be 3.2, or 32 over 10, or 16 over 5. So the basic idea is that similar shapes will grow and shrink by the same amount. Let's try another one. And I'm sorry I'm not able to draw as easily with this digital pen. My triangle lines are very crooked. So I've been going left to right, and you may say, ask, can I go right to left, and you can. So go ahead and pause it and try. How would you solve this? If we're being careful, this is our hypotenuse, and this is our hypotenuse. They're across from the 90. So they go together. Then this is the bottom, and this is the bottom. They go together. I said I was going to do it the other way, so let me set it up again. So I went right to left, right to left. It is also okay to go right to, I went left, right, right. It's also okay to go right to left. 4 goes with the hypotenuse 120. But you have to go back to this one. 3 goes with x. Both of these, when we cross multiply, 4 times x and 4 times x, we'll end up with the same answer. 4x equals 360. 4x equals 360. And we divide by 4. We get 90. So if we can match sides, then triangles are similar, and we can set up a proportion and cross multiply. So these are matching the actual pieces of the triangle. The bottom, hypotenuse matches with hypotenuse. Then we learned a specific triangle that has to be right. And what people had found is if you take a right triangle, here's the right angle, if you go and get the altitude, which is from the very top of the right angle all the way down perpendicular to the other side, we have actually 3 similar triangles. So if I take out this triangle on the left, I'll color it blue, and draw it by itself, it would look like this. The small leg is A, the long leg is X. Then if I take this other triangle and rotate it, and I'm coloring it yellow, if I rotate it this way and face it so it's facing the same way, you're going to have the short leg on this one is X, but the long leg is C. So because these are similar by angle, we could see this short leg will match with short leg. This longer leg will match with this longer leg. In doing that match, you will get A goes with X here, the smaller leg, and then X will match with the longer leg. And we see this is referred to as the geometric mean. It's going to give you a form of average. It's really like turning things into a square and finding the square root, so we know how much each side is. But instead of redrawing and pulling these out the way we did, we just learned a pattern. A over the middle one, the altitude, equals the altitude again over the other side. A over X equals X over C. So let's see how that would look in a real problem. 8 over x will equal x over, I was going to put 4, let's do 10. 8 goes with the middle one, as the middle one goes with 10. But don't be fooled and always put x twice. A lot of students see that x shows up twice because it's possible that the number will come up twice. We'll look at that in a moment. So if I cross multiply, I get x squared, and then I get 8 times 10. It's 80. The last step is to do the inverse or opposite of x squared is square root. And a whole other lesson, if you're not familiar, is how to reduce a square root. We factor it. 8 times 10, which is 2 times 5, and 2 times 4, which is 2 times 2. So the factors of 80 are 2 times 2 times 2 times 2 times 5. We've learned to circle the pairs, take them out because we're referring to one side of a square. So for every 2 we pull one out. And we get 2 times 2 radical 5, or 4 radical 5. But again, this only works when it's a right triangle and has an altitude. So you have to be able to recognize that triangle shape. If we forget the formula, we could separate them and match sides. So let's look at one more, and then I'll give you the harder version. Maybe the number here is oops, put an x. So the number is in the altitude rather than a variable in this spot here. Again, this side divided by the altitude equals the altitude again divided by the other side. And we'll get this time 6x equals 100, and we'll divide by 6. So notice that the x doesn't repeat unless the x is in the middle here. So a more challenging problem would be something we did see on a few worksheets. When they give you something like this, and up here is the variable. So you cannot use the pattern. So again, we can make similar triangles and compare sides. That's possible. We would use this big triangle, and we would use the medium triangle. So we could rotate them and make them match the pieces. But the other way we could do this is just add another letter here and do the pattern. 6 over y equals y over 8. Y squared equals 48. Square root it. Again, we factor 12 times 4, or 2 times 24, 2 times 12, 2 times 6, and then 2 times 3. So the factors of 48 are 2 times 2 times 2 times 2 times 3. We take out a pair of 2's, and we get 4 radical 3. So if I do that, I now have 4 radical 3 here in this triangle. I have 8 here, and I have x here. I could use the Pythagorean theorem. So it is still possible, if you're looking for an outside piece and not the middle one, we can still use the middle one, use the pattern we learned, find the middle one, and then use the Pythagorean theorem. So that is the pattern we use with right triangles. There are 3 other patterns. We learned when there's an angle bisector, which would show the angles here being cut in half. We learned when there's a triangle with parallel lines. By angle, angle, they end up similar. And the third one is just a variation or a version of the third one. It's when we have three parallel lines and it's aiming towards a triangle but doesn't finish. All three of these have the same pattern for setting up the sides. Now this particular first one is the sides and the bottom. A over B will always match the proportions of the other side, the right side over the bottom, equals C over D. So again, this one over this one will equal this one over this one. That same pattern is going to work for the second version. A over B equals C over D. And again here, the proportions of this piece and the one below it will always equal the same growth or shrinking proportions of the right side divided by the other piece on the right side. So we've used these many times. We'll go over a few. But before we do that, let me show you something important about this middle one, where every now and then they'll throw in a problem to try to trick you. Notice on this particular formula pattern, we have no bottom pieces of the triangle. So don't be tricked when you see that. Let me show you how you're sometimes tricked. So watch out. If you have a triangle like this, and the lines are parallel, you might have x and 4, and 30, and 50. Some students are tempted to set this up. X over 4 equals 30 over 50. Why won't that work? It won't work. Well, remember the pattern we just finished looking at. What it really looked like was A over B, x over 4, equals the other side, C over D. And we don't have those sides. So that pattern only works with the sides. If we're not given the sides, we need to just look at these as if they're any other type of similar triangle. We have to separate them. So the x is here and the 30 is here. Now we get the whole big one. 50 is on the bottom, but how much is this piece, right? It's not 4. So that's why if we put x over 4, we're only looking at this piece, not the whole triangle. But 30 represents the whole piece, 50 represents the whole piece of this triangle, x represents this piece, so we need to represent the whole side to match with it. This needs to match with x, not just a piece of it, not just the 4, which is from here to here, a little small portion of it. So we actually would have to add these together. X plus 4. Now we could match them. X goes with x plus 4. 30 goes with 50. Let me show you it again in another example. Some would say 4 over 8 equals x over 80. And again, that only works if we have these numbers here and here. This side over this side equals this side over that side. That is the pattern. When it comes to the bottom now, we're talking about similarity in a whole triangle. So whenever we see that bottom piece, we can't use that pattern. We're going to have to separate the triangles. 4 goes with it. 4 and x are the small triangle. 80 is in the bottom of the big triangle, and we got to consider what is this whole side. Well, it's not 8. That's why 4 over 8 won't work. The whole side is 8 plus 12, which is, 8 plus 4, which is 12. So now we can match it. 4 goes with 12, x goes with 80. And we can cross multiply. So 12x equals 320, and then we divide both sides by 12. But let's look at the times the pattern does work. That was just a warning to watch out for. Here's one of the ways we would set this one up. X goes with 12, 3 goes with 10. We're dealing with this side and this side, this side and this side. And then we cross multiply. How would you set this one up? And you could do 80 over 64 equals x over 12. You can do the start on the left or start on the right. X over 12, this over this, equals this over this. And really, if we're honest, we could do bottom, top, bottom, top. We could honestly do 64 over 80 equals 12 over x. But you don't want to get too involved in all the different combinations. So then again, we then cross multiply and solve. How would you set this one up? And so again, 82 goes with x. 49 goes with 32. We often do this and just set them equal. When we cross multiply, we get 49x and 32 times 82. So if you set it up slightly differently, maybe you went right, left, just make sure the 49 and the x go together when you cross multiply. How about this one? So if we rotated it, right, it would look like this. X and 22, 84 and 30. Technically, that would be the way we learned the pattern. X goes with 22, 84 goes with 30. So 30x equals 22 times 84. However, we also learned that you can go up, down, up, down. 84 over x equals 30 over 22. It will still work. And when we cross multiply, again, the 30 ends up with the x. So it ends up with the same answer. So I'm not continuing to solve it, just seeing if you can set it up correctly. We're assuming you can get x alone. So let's try one last one. How would you set this up? Pause it, try it. Did you put 12 over x equals 33 over 44? Because if you did, you are wrong. Did I trick you? So this was the type that we just finished looking at a few practice problems ago. This was the one that is not following the pattern we learned. The C and the D are not there. It's got the bottom being used. So in fact, we have to separate the triangles. 12 and 33 are the small triangle. 44 is on the bottom of the big triangle. And x plus 12. X is just a piece of the big triangle. We really need the whole left side, x plus 12. So 12 goes with x plus 12. 33 goes with 44. I want to make this a little easier to cross multiply. I'm going to reduce it. 3 times 11, 4 times 11. So the 11s cancel. That will make it slightly easier to cross multiply without a calculator. 3 is going to multiply to x plus 12. Don't forget, it will multiply to both, not just one. And the 4 and the 12 will multiply. So I have to distribute here. And then get x alone. Subtract 36. 3x equals 12. Divide by 3. X equals 4. So those are the patterns we learned for similarity. We learned how to test for similarity. We learned how we can match the sides of similar shapes and set up a problem to cross multiply. We learned the 3 patterns we just looked at. And then here are the 3 patterns. No, is that it? There they are. We learned the 3 patterns, and we also learned the one with a right triangle. X goes with A, as A goes with Y. Similar shapes grow and shrink with the same scale factor. Again, the angles are always congruent. They have to be exactly the same. The sides, however, are not the same. They're not exactly the same. They're going to grow and shrink by the same amount. When things grow and shrink by the same amount, we call that proportional. They have the same scale factor. And so that's why even in the 30, 60, 90 triangles, all 30, 60, 90 are similar. So we learned in the 30, 60, 90 ratio, let me make it look a little more accurate. We learned that the small side's 1, the hypotenuse is 2, and the long side is radical 3. So we can actually find any 30, 60, 90 by matching the sides because they're similar. So it works the same way. 1 goes with 10 radical 2. And the longer side, radical 3, goes with x. When I cross multiply, I get 10 radical 2 times radical 3 and 1 times x. And we know we could multiply radicals and radicals together. So the answer is 10 radical 6. This is actually leading into sine, cosine, and tangent. And each of the degrees we learn in the next chapter are going to be based off of similar triangles, which is why our calculators are programmed with certain proportions. So hopefully this was a little bit of a review. If you were absent, you were ill, if you needed to brush up before the test, but hopefully the basic ideas make a little bit more sense.